As the climate changes, tree fruit growers will need to contend with more intense and erratic weather. There has been a documented change in the amount of precipitation received during intense rain events. As you can see in this map, every part of the country has seen an increase in the precipitation received during these events, compared to that which occurred up to 1958. Here in the northeastern U.S., we've seen a 71% increase. In addition to the documented increase in precipitation during intense events, there are predictions of increases in erratic weather. Erratic weather can lead to increases in non-tornado winds. An increase in these types of storms during our warmer months of July and August is expected. This means we'll get hail more often. Hail nets, as seen here, may be necessary. Erratic late-season weather resulted in massive flooding during Hurricane Sandy in the fall of 2012. In New Jersey, peach orchards were flooded. Peach trees usually die if their roots are flooded for more than 48 hours. Short-term droughts of 1 to 3 months are also expected to increase. Erratic rainfalls will make supplemental irrigation necessary. Drip irrigation will supply sufficient water as long as we remember that drip is not a catch-up system, and we have to stay ahead of water needs. With increased carbon dioxide levels, there will be a concurrent increase in the rate of photosynthesis in trees. This will lead to more vegetative growth of trees, more flowering, and more fruit. Some estimate the increase in growth can be in the 40 to 55% range, with corresponding increases in yields. High summer temperatures could result in increased sunburn on fruit. Trees also transpire more during high temperatures, leading to more water stress. We can also get increased incidence of physiological disorders, premature ripening of fruit, and decreased shelf life of fruit. Finally, when temperatures reach above 95 degrees Fahrenheit, photosynthesis is reduced. Over-tree irrigation is the most versatile method of providing moisture, frost protection, and, potentially, fruit cooling to enhance fruit coloring. However, it's the most costly system to install in an orchard. Those are some of the potential impacts of more intense and erratic weather on orchards. With a changing climate, there will be changes in pest populations that growers need to deal with, including insect pests, diseases, and weeds. First, let's discuss how insect pest populations may be affected. There are many unknowns when it comes to how insect pest populations will change. While insects respond primarily to temperature, they also respond to day length and food quality. We may see earlier emergence of insect species, including all our major insect pests. This could lead to more generations of pests per season. Fruit flies and other pests may survive the warmer winters. We may even see regional movements of new species of pests. With longer seasons and more generations, the potential for greater genetic recombination and a shifting of susceptibility to control measures can occur. Now let's talk a bit about the effects a changing climate will have on tree fruit diseases. Some of the issues with disease pressure or incidence will be similar to the issues we just talked about with insects. Similar to insects, a greater number of generations could lead to more genetic recombination. Diseases such as black rot on fruit that is common in the southern U.S. may move north. More scab inoculum and all powdery mildew inoculum will survive the winter. Rusts may have more early season infections, and warmer temperatures during bloom may lead to more infection periods. Intense weather and winds may lead to more trauma blight. All this could lead to the greater need for antibiotic applications, followed by the potential for antibiotic resistance to develop. Finally, a changing climate will impact weed populations. Higher carbon dioxide level will add to the growth of fruit trees, but will also increase the growth of weeds. With increased rainfall amounts and intensity, herbicide residues will decrease more quickly, resulting in a shorter period of weed control. Warming temperatures may facilitate the dispersal of common weed seeds, such as ragweed. Finally, increased growth will mean greater vegetative cover that dries in the fall and increases the potential for fires. That sums up our analysis on some of the potential changes we'll see in insect, disease, and weed populations.